Okay, looks like we are online. Happy Saturday. And today is the first day of May. So we have the first day we have two questions because paid I have a paid membership. So there is one locked question for the paid membership, and then the other one is for the free membership. And I checked the both of them. Well, the first one is the number of connected component in a undirected graph. And I checked, this is the median question, number 323. And according to the history, I didn't do this in the past. And the other one, the free tier one, well, that is a hard question. So if you notice, I didn't put the I didn't put the hard one on the title because I don't know. Well, that is for the free membership. I don't know if they encourage people to do the paid membership because this one is a hard question. So the reason why I didn't put it on the title because I don't know if I can solve this um, before the deadline today on the stream. So I only put this one on the stream title. So that's what we are going to do today. We are going to first try this median question, and then if we still have time, we will then try to see if I can solve this hard question. But most likely, I will probably, if we have time, I will probably look at the solution and the discussion to see how other people solve this kind of hard question because I am probably not able to solve it. I don't know. So anyway, so let's try. Let's try the first one. The first one, the number of connected component in a undirected graph. So you have a graph of n node. You are given an integer n and an array edges where edges I equals to a and b, and then that's indicate that there is an edge between a I and bi in the graph. Return the number of connected component in the graph. So for the example 1, the input is 0, 1, which means there is an edge between these two vertices. And then 1, 2, edge between these 2 points. And 3, 4, edge between 3 and 4. And n is 5, means we have 5 points starting with 0. So the output should be 2, which means that we have 2 connected components. And the other one, we have 5 points, 4 edges, 0, 1, 1, 2, 2, 3, 3, 4. And the return value is 1, which is 1 connected value. So I think as a number below 400, I think this is a typical classical LeetCode question. So I think this is okay. So let's see the constraint first. Constraint is we will have between 1 to 2,000 points, and then we have between 1 and 5,000 edges. So it didn't say if there is a cycle. And then the edge length will be 2, so it's saying that this array length will always be 2. And we think this AI will always smaller than BI, which means we won't have duplicate. I mean, yeah, and then A is smaller or equal than BI, so we might have like self edge connect to themselves. And a what? But they say AI is not equal to BI, so we won't have a. Okay, so although there is a less than equal, but there also is a constraint telling that the 2 point will not be the same, so there will be no self-connected edges, and there will be no repeated edges, so those will not be repeated. So I don't probably think repeated or not is something that's so important. The only thing that I'm not sure is that, hold on. Yeah, we could have this many of edges because every 2 points could have one edge, right? So this looks like a classic problem of either you can do a DFS or you can do what's that called, union find. So, and it's just a simple DFS or a simple union find. Now I'm not sure which one is faster, so let me think. DFS will only visit each point once. Union find will also only visit each one once. And somehow I think union find will be slower. But the big O should be the same. I mean, I think it's constant time slower, but the overall big O timing is the same. So it just depends on which one you want to practice with. And because we usually have a lot of DFS, today let's try union find. Maybe that's a better challenge for us to try. So let's try it. So how to do a union find? First, we need to have like array of parents, and then we are going to have array of level so that we can do the level compression. And then since we need the number of connect component, so we will have a connect, 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 or count. Let's just do count. Okay, let's do CNT. So it's count of the connected component. So when we start the program, we have count equals to n because we have n point. So at most they will have, if there's no edge, there are n component, n connected component. Well, and separate component. Anyways, and then we will also need to initialize the parent as an length of n, and also we want to initialize level as n. So after initialize, we then need to initialize their parents. So initially, if there's no age, every point has their own parents. And now now the number, because it's 0 based, so it's starting with 0, so we don't need to so the index will point directly to the array index. So in other way to say it is that the point number is exactly the index number. So let's initialize their parents. So parent I equal to I, because initially their parents are themselves, which means they are not connected. And now we go through each age. So for int e in the adges. So for each edge, we on net, which means we union them together. We union EDGES, no, E0 and E1. Do we need to do anything else? I don't think so. And then we return CNT, because CNT is our connected component. So now that's the basic, I think that's the basic main program, and we need to do the union and we need to do the find. Okay, so let's do a private. Let's do find first. Find what? So let's do INTA. So what we are going to do is like while do we need while? No, I somehow forgot how to do the union find. Okay, so if parent A is not equals to hold on, how to do a union find? I somehow forgot. So we need to find A's parent, right? So A will stop while A's parent is itself. So while A's parent A is not A, then parent A equals to find parent A. Because if A's parent is not A, then for example A's parent is B, then we'll try to see who is B's parent and return B's parent, right? I think so. So this is the find, and let's do union. Let's void union TA and TB. So INTPA equals to find A, INTPB equals to find B, and if PA not equals to PB, then we union them. So if PA not equals to PB, then we compare the level. If level PA is larger than level PB, so if A's level is larger than B's level, then we hide B under PA. So then parent PB equals to PA. Else, if level PA is smaller than level PB, then parent PA equals to PB. Else so this else condition is level EQUAL. So when level is equal, no matter which one we connect to which, the other one's level will add 1. So if we don't care, then we will just do one of them, and then because now PB's parent is pointing to PA, so now PA's level will be increased. Okay, so is that right? Is that right? To do this is just to try to make the level not too big. And to do this is just trying to do the compression. So if A's parent is PA, PA's parent is PAP, and then we directly assign the value of PAP into the value of PA, so that we compress this level, we compress the path, right? Because we don't want to trace like PA's parent is B, PB's parent is C, PC's parent is D, PD's parent is E, and then we need to compress them so that PA's parent is E, PB's parent is E, PC's parent is E, so on and so forth, so that every point, if they share the same parent, we can only do it once and directly point to the parent. So those are the union find, I think. Oh, by the way, we forgot to decrease the count. So if they are not equal, after we connect them together, the count will decrease by 1. Okay, I think that's it. Let's try it. Yo, it looks like it works. So we have 2 examples. Let's try another one. What? Okay, looks like both works. Is there any edge cases? Probably not, because edge cases probably will be 1. And because there will be no duplicate and there will be no set point edges, so the edge will be 0. And the 2000 edge cases is too hard for me to generate right now, so I will skip that. But for the 1 point, let's try. There's only 1 edge case, so why not just try it? So 1, and there's nothing. So yeah. Yep. Okay, so it's just the classical union find question. So let's try to submit it to see if we pass. Yes, we passed. So, and let's see more details. So I'm here 100% large, so I think it's probably because union find is faster than DFS, so I was wrong, because I somehow think that union find will be slower. And the memory usage is larger than half of them. Why? Will DFS use less? DFS might use less. It all depends on the system stack because you are recursively calling the DFS. But hey, I am already satisfied that I passed this one. So one down, another one to go, but I am totally not confident that I will pass this. Shoot. Okay, anyway, since we do this quickly, we finish this quickly, so let's do this. Prefix and suffix search. This, let me update our stream title. Let's update the stream title. Can I update it during the stream? I'm not sure. Update info. Did it update? It looks like it did. Okay. Oh my god, this is a hard question. Let's try it. So it's number 745. Prefix and suffix search. So number 745 is already out of my usual LeetCode range, which is 400. So it might be a little bit difficult for me to do. But anyway, there's one hint. Why not try it? Okay, so let's read the question first. So number 745. Prefix and suffix search. Design a special dictionary which has some words and allow you to search the words in it by a prefix and a suffix. So implement the word filter class. So if you put how to say that? I forgot. Anyways, initialize the object with the words in the dictionary. And then F. What? The function is called F? Just one single character. Okay. F. Prefix, suffix. Maybe this is Control F or something, which means find. Returns the index of the word in the dictionary which has the prefix and the suffix. If there is more than one valid index, return the largest of them. If there is no such word in the dictionary, return -1. So like we call the how to say that? I forgot. Anyway, we call this with Apple only one word, so the dictionary has only one word, and then we try to search the prefix A and suffix E. Return null. Oh, return null is the first function. Initialize this and return null. And then second one will find the Apple, and the Apple is in the index 0, so it will return 0. Wow, this is really not a good example, right? I mean, I sort of understand, but it didn't really describe anything. So okay, word filter, initialize, return 0 because the word. So okay, so for the word length is less than 15,000, and each word will less than 10 character, and the input prefix length and suffix length will be between 1 and 10 so the prefix could be the entire string. Okay. Okay. Consist of the lowercase English only. Of course. At most 15,000 calls will be made to the function f. It's alright, it's alright. But okay, I think at least you give me an example of what do you mean by the largest index. So you mean that your input is not sorted. So I have to remember your order of input. Is that what you mean? Okay, so uh the constructor. So I remember there is a string function called start with in Java, but I don't know if there is a function called end with in Java though. So if there is a suffix that might not be working, let's try search. Why not? Java. Java what? Java string. Start with. No? I have a typo. Okay, star index of interval. Yes, starts with, but I don't think there's an end with, right? Nope. Oh, there is an end with. Okay, so the easiest way is to like go through each of them, and because we need the largest one, we go through from the back, and then we do the start with and end with, and then it will be it. But I am pretty sure there will be TLE because this is a hard question. It's not supposed to be that simple. So do I want to try it? I kind of want to try it. It looks like, oh, there's a hint. We forgot to read the hint. For a word like test, consider test. What do you mean? Test. Then if we have a query like prefix te, suffix t, then we can find it by searching for something with insert start with. Oh my god. Okay, I sort of understand. Okay, so for each word in the dictionary, we will insert but I'm so curious. If we have a start with and we have an end with, why don't we use that? I think that will be probably good too. But consider that we have 15,000, that might be run out of time. So from the hint, it looks like we are going to implement a try, and for each word, like if there is a word in the dictionary test, we will try all kinds of suffix and then insert it into the try, and then try to find a match in the try. If we find a match, how the hell do we know that it's the largest index? How do we know that's the largest index? hold on, don't tell me that this is not going to do a try. We are going to do a try, right? But after we have the try, like if we have a prefix te and we have a suffix t, are we going to, and then we combine the suffix to the te, so we will have something like, hold on, let me just use this. So we will have t, we will try to find a match of t and te, right? Consider if this is the case. And we will land in this one. How? I mean, how? So along the way, I will stop at this point. Okay, so from this point, am I going to go do a like scan? What's that called? Traversal. From this point as a route, I traverse all the different branch and get all the words in there and find their index and return the, hey, thank you, Matthew. But this is a hard question. I'm trying to yeah, so now my thought is that from that point I will do a traversal to all the endpoint to try to find every leaf for the try, because every leaf represent, not every leaf, I mean every point might represent a word, and that point I will save a list. Should I save a list? No, each point only represent one word, so I only save an integer of index in there, and then I only need to find the max. Is that, will that work? I think that should work, because if we are lucky that the prefix and suffix are long enough, we are supposed to not find so many words within this branch. So let's try it. But oh my god, we just implement union find. Now I have to memorize how to like recall, brush up my skill of implement a try. Try. Okay. So let's do it. Let's define a class called try. So class try. A try will have, or this is not a try, it's a try node. Oh yeah, try. Yeah, thank you. Yeah, I think try should work. Well, but the difference between these two questions is like this is less than 400, so it's a classic union find. You don't, there's no anything that you need to modify the union find in order for this to work. But I think this, not only that you need to know try, but also I think you need to modify it a little bit so that it fit into fixing those type of problems. So yeah, but I will try. So we have a 26-way try. So int of try. And what else do we need? Oh, probably an integer is enough. Index. Probably an index is enough because there should be no duplicate, right? It's a dictionary of the non-duplicate words. And then if we call try with char, so int this dot try will equals to new int 26 and index -1, which means we have not assigned a word in there. And then to initialize it, we just for int string word in words we need a something called insert try. Okay, I kind of a little bit lazy and I want to do a static function. Just iterate through the try. Yeah, let me think about it. So of course I need to insert word, but of course I need to initialize the try. So like try, I probably should do this. Try root is new try, and then when we insert try, I pass the root. Okay. Oh no, not that easy. We need to do this, right? We need to do this stupid thing. So we need to also yeah, for each word we need to like while. Oh, my cat is clicking for me. Please don't. Thank you. While what? So while so we need to new a string suffix equals to new string and then 4 now wow, so 4 unti equals to, so we need substring start from start from the length. So the length is word, the length can spell word dot length, I equals to word dot length, I larger or equal than 0, I decrement, and we want to insert, this is the root, and what we are going to insert is blah 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 blah. So the original word, the substring from I to word the length length plus, okay, I feel like I'm cheating because I do exactly what the hint want me to do. So okay, so I go through the for loop. So the first one will be, this one will be an empty string, right? Because from the length to length is an empty string plus this, and then we decrement the I. So the second one will be this, third one this, fourth one this, until eventually we have 0 and then the entire word plus this. Okay, so we insert this. Now we only need to implement. We still have time, right? Okay, we still have 1 hour. We only need to implement the insert. So like I said, I don't want to do this within the class. I think it's easier for me to do it as a static function in here. So private. Do we need to return anything? Not yet. I haven't thought of return anything yet. And it's called insert try. And we will have try. It's a little bit confusing. Let's just, anyway, root. It's not a good naming though. And string of the string to insert s. Let's just do s. Now, I think you're good to start. It's not a, but usually people should not see the hint until they really can't find anything, right? But anyway, I really can't find anything, and I really don't have any thought of doing this. Because originally I was thinking that if we are going to do try, we will probably do 2 tries. So one is like the original word, and then the other one is reverse words. So for you to search the suffix, and then, but the downside of it is that after you search the prefix, you will, and then you traverse all the list to get a list of words. You will do the same on the other try, and then you will get a list of another, like another list of words. So now you have to compare, right? So you probably put all the words you find in the first try into a set, and then traverse through the second list to see if they are in the list, and then compare them to get the maxima. So that's my original thought. But now this one seems easier because you only need 1 try. But the downside is that for every 1 word, you are inserting a lot of word. And yeah, and also I forgot I need to insert the index because we need to know the largest of them. So I cannot do this. I need to know the index. So I already used the y in here. So let me, I totally forgot the index thing. So I need index. So int, somehow I already used I, God, J equals to 0. J less or equal less than words dot length. No, it's an array. Huh? Where is? And J increment. So the word will equals to like WORDS J, not I. Then this could be the same. Suffix is a new string. Anywhere I need to change, and I probably will need a J. Not so J. So here I will probably need a int. Let's call it IDX. Okay, inserting. For the try, you should have try as the children in your try class. Try as the children in the try class. Yeah, this is the one. Oh, God. Yeah. Why I type int though? Okay. Yeah. Thank you. So it should be a try class. Try array. Try array. Okay. Yeah. I keep thinking int. I don't know why. Okay. Now I need to implement the insert. Do I do iteration or do I do recursion? Which one is easier? Anyways, so let's do the okay, and then it's better for me to also okay, now it's a little bit confusing. I want to have the index of the original array words. I also want to know what is my current index in the words. I somehow use index. So how do I name it? Do I name it cur? Hope that's not too confusing. So like initialize it. How? So if cur is larger or equal than s.length, then this root is the endpoint. Root dot what? Oh God, I call IDS everywhere, so it's now a little bit confusing. Let's do. But they are really indexed. I can't name it correctly. How about let's do this like position. Anyway, they are already indexed. So root dot index equals to index. That's what we are doing, right? So and then we can return. Is that right? 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 Ah. Otherwise. Hey cat, don't block my screen. Okay. I think I'm going to do a recursion. So it will make the code look cleaner. Although there is a stack that you can control. But yeah, let's do recursion, right? Otherwise, int I equals to s dot char at cur minus a and now if root dot try not try why are so, yeah why are what okay yeah why don't I call it children though? Why I always have typo? Why my cat is blocking my screen? I can't see. So this is try. This the child is a new try. Okay. Don't step on my keyboard. Okay. You sleep. Oh my god. Okay. So I call it a child. Yeah, I should call it a child. I forgot. I don't know what I think. I do an integer try, but it should be try child. So yeah. So now that in here, if root dot child children I is null, then let's do then let's new something for it. And then if we are doing the recursion, I call this same thing again, right? So the index is still the same. The child is the new one. Oh, don't step on my keyboard, please. And where am I? Did I copy it? I did not. And then the string is the same string. And then cur plus 1. So if I do recursion, that should be it, right? I hope so. Let's fix it later if there's any problem. So let's implement the f. So now we have a prefix, and we have a suffix. Of course, let's get a new string of, how to call it? Key? Wait a second. Oh yeah, key. It's okay. Name is not that important. So according to this, we are going to, according to my note, we are going to do the suffix plus this plus prefix and we need to have a search try, and by doing this search try we should get a list of the index, shall we? Or we just directly return the largest one, and within our search try we determine which is the largest one to return. So we just need to return search try, but I need to make sure that the search try will return -1 if there is not a match. SEAR, Sears already bankrupt. SEAR search. Okay, yeah. Yeah, maybe that's it. So now let's implement the private integer is what we are going to return. Search try. Let's see what we are trying to. So at least I need the key, right? Is the key the only one that I need? I need a root. So no matter what, I need a root. Will this naming confuse? Because I'm using root in here too. And then I need this dot root, or maybe not this, but I shouldn't name this. Let's call it node. How many times I do this? Yeah, it's looking better, so that maybe I don't need this. Now I won't confuse myself. Right. And then, and now that if I make it here, why am I passing it? Oh, because I'm doing the recursive call, so I need to pass one of them anyways. But in here, search try, am I also going to do a recursion? Which one is easier though? Recursion? Maybe recursion is easier. So if I'm going to do a recursion, I also need to pass the root. Tour is what? What is tour? ROOT. Okay, I guess that's it, right? Yeah, so although our root is global, but because I'm going to do search try in a recursive way, I need to pass the root. String, I still call it key. Maybe I can call it S, because I call it S in here. And the try node. So first, what's the ending condition? if oh if now I need a cur too. So why my cats won't move? It's so hard to type. So our ending condition is that we reach to the end of the S, right? So it's the same again. Let me copy and paste because I can't type. It's this. If we reach to the end, we are going to do a depth first search. DFS. And how does this DFS return the maximum one? How does it return it? Shall we return a list? Or during the DFS we can just directly compare the value to keep the max one to return. So it should be okay. So let's put it here first. Let's finish the search try first. Okay, so if we are not end yet, so I am supposed to do the same thing in here, right? So I have this. I got the index of the current character, and then if oh god, so good that I can just copy and paste. If this is null, then we return -1. Oh, let's put node in here first. I will need no anyways. Okay, so if we ever reach a null child, which means there is no match, then we directly return -1. Otherwise, we are going to do a recursive. Wow, I'm so surprised that the code is so similar to the insert try. So why do I not copy it from here? Why do I not need an index? Oh, because I don't need an index. And I can even copy this. I'm surprised. Yeah, I think that's probably it. Oh, no. Return. Yeah. Recursion makes the code cleaner, I think. So that's probably it. Now we need to implement this. I think hey cat, can you sleep in here? Can you? No. Okay. So we are going to still return the int, and then it's called DFS, although it's a traversal, but anyway, it's the same thing. And then we have a try. I am going to still do a recursion. Oh, it's recursion everywhere. Is that good? Okay, so I will need probably to pass the current maxima, which is -1, and it will not return -1 anyways, because if there is a try being generated, and the try will only generate in the insert try, right? So if the try is not null, and if we are able to search this non-null try, which means there must be something, some number saved under the try rooted as node, use node as a root. So the DFS is definitely going to return something, not -1. So the thing is, if we reach here, we are definitely going to get a number. Is that right? That should be right. That should be right. And you only need an index, right? Yeah, you only need to return the index, which is good. Because the thing is, yeah, I didn't, yeah, index is enough. Because I never saved the original words. So now that even if I got an index, I cannot return the original word. So yeah. But anyway, it only requires us to return the index, I think. So DFS. How to, what's the, so I keep a current maximum. int max. And now let's update the max with the current node number first. So if node node what? Node dot, what do I name it? Index. Okay. Node dot index is not -1, and I insert it. No, then I don't need if. So just math node, not node, max equals to math the max a node the idx max. I'm not sure why we need DFS here. We just simply compare I'm thinking doing a DFS is because now, for example, for the hint here, right? For the test, we insert this many string, and when we insert each string, we insert the, we put the IDX in there, right? So suppose that test is in the input index 1, right? And then now we are searching, our search key is this. But you cannot guarantee that this will find this word only, right? Because if in the original dictionary, so this is for test. So if for the original dictionary, like words, we have like the first one being text, and the second one being test, right? So the reason why I'm doing a DFS is because you see now the key will find two matches, one being text, two being test. So when I reach the point, the node t at number te, I will start from this node and traverse every branch to find text and find test, and maybe find other start with te, end with t, and then compare their index and return the maximum. So if start from here, I have like another one being like TE, like A, B, C, D, E, T. So I need to traverse all these three and then compare their index and return the maximum one. So that's why I'm thinking that after we reach this point, we need to do a DFS to traverse through all this and then compare and then find their maximum. So if I DFS, first node I encounter is this. Yeah, so that's why, because it said, that's why, because they said return the largest, which means you are definitely going to find a lot, right? So that's why I'm doing a DFS. So now, first we update the max with the current node's index if it's not -1. Well, even if it's -1, we are updating -1 to a -1, so it won't bother. So now from this point, we will traverse through. So for int I equals to 0, I less than node dot size dot child dot length. Maybe I can just type 26. And then we are going to do a DFX, right? So I am just curious, is this the best way to do it? So the node will definitely, hold on. So we are going to do a DFS. Oh, that's so stupid. So we pass in the max. We pass in the node child. Node child what? I? Is that the best way to do it? It looks a little bit stupid though. So this will return a number, and then we compare with the current max to get the max assigned to max. I am not even sure if that works. And then we return max. Will they compile? That's a little bit ridiculous. So we test this. This will return a number, which is the max below. And then we compare to the current max and then assign to the max and return the max. Okay, let's assume that work. Do we complete already? F. So try return. I don't know, it looks like I don't have nothing more to do, so let's try it. I will have compile error. I know. Line 5. Oh, God. I will have another compile error, I think. Yes, why? Oh God. Do I have more? 53. Oh, shoot. I can't spell. Do I have more? 53. Anyways. Out of bounds in line 33. Index -62. Oh god. This one. Just because of this one, I cannot do a 26. I should do a 27. So the last one will be this. Okay, so in the insert try, so after we have this, so it looks like the ASCII number of this is way smaller than A, although I don't remember what's the number of this, but it turns out to be negative 62. So I want to assign it to cat. What did he do? Control Z. Okay. I want to assign if this is out of bound. And then if I is less than 0, I equals to 22, 26. Okay. A little bit stupid, but that fixed this in the insert try. And then in here I need the same logic. Did that fix it? Did that fix it? I hope so. I sure hope so. Null pointer 53. So this node, why am I, so yeah, I should check first. Oh my god, I'm so stupid. So not only I need to check this first, because the first time I called it, in here I checked, but in here, because the first time that I call it is from F, in F I didn't check, right? So now that I check in the beginning of this, do I still need to check in here? Probably not. So let's delete this from here. So now if I check this from here, do I need to check in here? I probably should. Where is my this? If this is not null, then do this. Yeah. So I just want to make sure that when we call DFS, this will not be null. So if I put the null check in here, I won't call the DFS with node is null. And then, so I don't need to do a check of the node in the beginning of the DFS. And I do it in here because I don't want to call it with a null. Should work. Yeah, but this one is definitely too easy. I mean too simple. So let's try another one. Da 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 da. So let's do our, okay, let's do, okay, I can't really see. Let's try our example. TE and T. So this should return 2, right? I think. Number of constructor arguments should be 1. Huh? Number of huh? Wait. Let me separate this first. Number of constructor argument. So I pass 3 argument. Oh. Yes, I shouldn't do this. Oh my god. Right. Do I have 1? Okay. So what if I add one more, like blah 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 blah? Okay, so what if I try to search something that's not there? Okay, so is there any edge cases? Like, one word we already try. The example is one word. Length is 1 to 10. We could try. So like, if I have like just T, and this should still -1, right? It's a little bit slow though. And then if we do a T, this is not T. Yeah, I find it. So if we have an empty string, should be still 4 because we have 4 start with the T. F argument invalid. Oh, we cannot pass something less than 1. So I guess we finish all of our edge cases, maybe. So it's probably time to submit the answer to see. Okay, what? Invalid. I didn't change it. It's a bit slow though. But let me submit it. We did it. So let's see. I'm only faster than 40%, but as long as it passed, I'm okay. I only faster. My memory usage is only better than 40%. God. Well, anyways, so I am so curious about the official solution though. So they have approach 1, 2, 3. They have 3 different approach. So first one is try plus set intersect. And this, oh god, this is the first one. This is the one that I thought, right? To try. To try. And yeah, I'm glad I read a hint. Okay, I'm so glad that I read a hint because this is my original thought. Like, we have to try, and then we search in the first try, and then we put everything the first try in a set, and then we search for the second try and try to find the intersect. And according to the solution, it's TLE. So I'm glad that I didn't try that, but I still feel like cheating though, because I know if I do it myself without looking at the hint, this is what I'm going to do. Pair the try. Pair the try. So pair try is still to try. So say we are inserting apple, we insert this into our try. Then if we have equal length queries like this, we can find the try in our try. This seems promising. What about the query that aren't equal? We should just insert them like normal, like so. We could create node try none because P is, oh god. After inserting the pairs into our try, our search looks straightforward. I think the second one is not that easy to understand. I mean, how do you come up with the idea of inserting the same length? Yeah, it's not intuitive for me though. Okay, so I bet the last one is the one from the hint. Yeah. So for each try, we generate each kind different of combination. And then, yeah. And then we insert it into the try. Okay. Yeah. Okay. And yeah, well, I couldn't analyze the time complexity though. Yeah, it's so complicated because the tries depth will be twice as long of the original string, and then so it's still constant to 2 times, so the depth is still constant, but the word that we insert are like the length of the string times the length of the string. No, the length of the string, because we are trying to use every suffix combined with the original string. So it's n times k. K is the maximum length of a word. Yeah. So m times k, and then the depth is also k, so it's k squared. And for the time is nk squared plus qk. What is q? Q is number of queries, because every query we will need to go through the, wow. So the time complexity is not that easy to analyze. Okay, but anyway, I forgot the time. I don't know how long. We probably spent more than 1 hour to do this. And did we submit before the deadline? Yes, we did. Okay. So that's good. I'm surprised that I finished this. So yeah. And thank you for tuning in. So I'm surprised that the first day they give us a hard question. And the even worse thing is that they give the hard question to the free subscriber, not the paid subscriber. So the paid subscriber like me got the easier one, and then if you check, they award you with the easier one for 35 coins. And if you complete the harder one as a free tier subscriber, you only get 10 coins, which good job, LeetCode, good job. Okay, yeah, but let's see for today's day 1 of May's daily coding challenge. So I will take a rest and then I will see you tomorrow. Thank you for watching. Goodbye.